So, hello student. In today class, we will discuss about new chapter of mathematics that was properties of triangle. Firstly, I will tell you some formulas. Then I will solve some previous year questions for of this chapter. Okay. So the name of the chapter is properties of triangle. Properties of triangle. Suppose this is a triangle. Any triangle can be there. Other than right angle triangle, or either it is a right angle triangle, isosceles triangle, equilateral triangle, and these formulas are applied to all type of triangle. This was A, B, C. Side opposite to angle A is denoted by small a. Side opposite to angle B is denoted by small b. Side opposite to angle C is denoted by small c. Now, firstly, the perimeter of triangle. We know that the perimeter of triangle is perimeter of triangle. So, student, what is so perimeter of triangle is sum of all sides. Sum of all sides. That means 2s is equal to a plus b plus c. So this was its perimeter. Now semi perimeter will be half of 2s. Now next will be semi perimeter of triangle. Semi perimeter of triangle. So semi-perimeter of triangle means the half of perimeter, which is denoted by S. So S is equal to A plus B plus C by 2. Okay. This was its perimeter. This was its semi-perimeter. Now the area of triangle. Third one is area of triangle. We know that area of triangle is half base into height, but in terms of S, we can write it as S minus A, S minus B, and S minus C. Okay. Now there are two terms. First is circumradius, and second one is in radius. So what is in radius? Suppose this is the triangle, and in circle enclosed by it. So the radius of that circle is known as the in radius, where r equal to in radius. In radius means the radius of a circle which is enclosed by a triangle ABC. And the formula of this in radius will be delta upon S, where delta denotes the area of triangle denoted by delta. Okay, delta upon semi perimeter. Area upon semi perimeter is known as the in radius of triangle. Now next is circumradius. Circumradius means suppose this is the circle and a triangle is enclosed by it. So a triangle enclosed by a circle, then the radius of that circle is known as the in radius. So circumradius. So r is known as the circumradius. Now suppose this is a triangle A, B, C. Side opposite to angle A is small a. Side opposite to angle B is small b. Side opposite to angle C is small c. So the value of R is ABC upon 4 delta. ABC upon 4 times delta. of delta is 4 times of area of triangle. So that was the value of circumradius and that was the value of in radius. Now next is sine rule. So in any triangle ABC, in any triangle ABC, this rule is applicable to all type of triangle, not only for right angle triangle. It was applicable for all type of triangle. Either it is equilateral, either it is scalene, either it is isosceles, okay, or either it is right angle. So this rule is applied to all types of triangle. Now suppose this is the triangle. The sides of triangle are angle opposite to angle A will be A, angle opposite to B will be B, angle opposite to angle C will be C. So in any triangle ABC, A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to constant. Mean the ratio of the respective side with the ratio of the side with their respective angle is always constant, and this constant is equal to 2r. So a upon sine A is equal to b upon sine b is equal to c upon sine c upon is equal to 2r. Generally we take it 2r. So that was the sine rule, or you can take as k. Okay. Now next is your projection rule. Projection rule. Next one is your projection rule. Suppose this is the triangle and the side of triangle are A, B, C. Suppose this angle will be projected to the side B at point D. Now the value of side opposite to angle A is A, side opposite to angle B is B, side opposite to angle C is C. Now the projection rule is A is equal to B times of cos C plus C times of cos B, and the value of B is equal to C times of cos A plus A time of cos C, and the value of C is equal to A times of cos B plus B times of cos A. Okay. If a perpendicular is projected to a side A, then the rule will be A is equal to B cos C plus C cos B. And if the perpendicular is projected to side B, then B is equal to cos C cos A plus A cos C. And if the projection is projected to side C, then the value of side C will be A cos B plus B cos A. That was your projection rule. Now next is your cosine rule. Next was your cosine rule. Cosine rule. Now in any triangle ABC, in any triangle ABC, the value of, firstly I am drawing the triangle. This was angle A, B, C. Side opposite to angle A is A, side opposite to angle B is B, side opposite to angle C is C. So in any triangle ABC, A square is equal to B square plus C square minus 2BC cos A. This was cosine rule. And B square is equal to C square plus A square minus 2AC cos B. and the value of c square is equal to a square plus b square minus 2ab cos c. So that was your cosine rule. Now, if you want to find the single value of cos A, then that b square plus c square come to left hand side, and the value will become a square minus b square, and this minus 2bc come in denominator. So the value of cos A became b square plus c square minus a square upon 2bc, and the value of cos B will become a square, sorry, a square plus c square minus b square upon 2ac. The value of cos c will become uh, a square plus b square minus c square upon 2ab. Now, firstly, look at the value of quotient rule. How you can remember? Here is a, and angle is also a. So if a will came, so angle a will be minus, okay, and other side will be b square plus c square minus 2abc, okay. And similarly b square, if b square is there, so there will be a minus of angle b, and if c square will be there, then there will be a minus of angle c. Rather, two sides apply the formula of a minus b whole square. Now similarly, in the formula of cos a, if there will be a angle A, then the side A will be minus, A square will be minus. And if there will be a angle B, then side B will be minus. And if there will be an angle C, then side C will be minus. Rather, two sides B square plus C square will be added, and in by they are divided. Rather, two sides are added, and in by they will be divided. So that was your cosine rule. Now, the area of triangle in terms of sine. Area of triangle in terms of sine. We know that the area of triangle is half base into height, or in terms of semi-perimeter as under root s, s minus a, s minus b, s minus c. But the formula of sine are 1 upon 2. Suppose this is the triangle A, B, C. Side opposite to angle A is A, side opposite to angle B is B, side opposite to angle C is C. So the value of area of triangle are half AC sine B. Next value will be half AB sine C. Next value will be half BC sine A. So that are the values of area of triangle. Half times of A into C, and which side will be left, that angle will come. Okay. Now see that if A and C side will become, then which side will be left? B. So angle of B will came. Okay. If A and B will came, so which side will be left? C. So C will came. If B and C will became, then which side will be left? A. So angle of sine A will came. Okay. You can remember simple as ABC, ACB, and BCA, and in which one of the angle have sine. Okay. That are the area of triangles in terms of in terms of sine. Now, in terms of circumradius, that was also your previous year question, that you have to prove R is equal to ABC upon 4R. ABC upon 4R. Okay, that was also your question. To prove that the R is equal to ABC upon, sorry, delta is equal to ABC upon 4R. Delta is equal to ABC upon 4R. In the last previous slide, we have discussed that delta is equal to half AB into sine of C, ABC, na? And in which one angle is C. Now, I am drawing the triangle A, B, C. Okay, side opposite to angle A is A, side opposite to angle B is B. side opposite to angle C is C. We know that the sine rule, that A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R. So if you see C upon sine C equal to 2R, then if I cross multiply, the value of sine C will become C upon 2R. So in place of sine C, I can put C upon 2R. So half ABC upon 2R is equal to delta. So where here I am taking as a circumradius, huh? Suppose that was R, the radius of triangle. So here will be R, capital R. So ABC upon 4R equal to delta. And you also know the formula that if you cross multiply R and delta, so R is equal to ABC upon 4 delta will be the value of circumradius. Okay. So from that formula it will come. And that was your previous year question that proved that delta is equal to ABC upon 4R. Now the next is your tangent rule. Tangent rule. So tangent rule means value of tan b minus c by 2 is equal to b minus c upon b plus c into cot a by 2 into cot a by 2. Next formula is tan c minus a by 2. So the value of tan c minus a by 2 will be c minus a upon c plus a into cot b by 2. The value of tan a minus b by 2, tan a minus b by 2 will become a minus b upon a plus b into cot c by 2. So that are your tangent rule. Tangent rule means the tangent of angle b minus c. If b minus c will came here, now see how to remember that formula. If b minus c come here in terms of angle, then their side minus and plus will be added. Okay, then their side b minus c, corresponding side b minus c upon b plus c, and the angle which has left comes in the terms of cot. Now see tan c minus a by 2, angle c, angle a, so c minus a upon c plus a respective sides, and which side will be left? B. Okay, so the angle of b in terms of cot will came. And if tan a minus b will be there in terms of angle, so their corresponding sides a minus b upon a plus b, and the angle which have left cos c by 2 will came. So that was your tangent rule. Okay. Now next is your next formula is your, this is also a proof. So we can do this question in terms this formula in terms of question. Okay, so what is the formula? This is your previous year question. Prove that cos A upon A. This formula come in your previous year question to prove cos A upon A plus cos B upon B plus cos C upon C is equal to A square plus B square plus C square upon 2ABC. Now, I am giving the solution of it, providing the solution. 1 upon A cos A plus 1 upon B cos B plus 1 upon C cos C. Firstly, I am taking the LHS. Okay. Now, what is the formula of cos A? How I will remember you the formula of cos A? Which two side will be left? B square or C square? So B square plus C square, and whose angle is this? A. So corresponding side will be A square, and in a by 2 times of multiply of left side. Similarly, 1 upon B is equal to cos B is corresponding side will be B. So B square will come here, and which two side will be left? A square, C square, and in by the multiply of 2 times of the left side. The value of cos C will be minus of corresponding side c square, and rather two side will be multiply a square plus b square upon and in upon 2ab. Now, and you have seen in a by 2abc, 2abc, 2abc. So I will take common 2abc. Then first b square plus c square minus a square. In a second, a square plus c square minus b square. In a third, a square plus b square minus c square. Now a square term will be cancelled, b square term will be cancelled, c square term will be cancelled. Now what will be left? A square plus b square plus c square upon 2abc. So a square plus b square plus c square upon 2abc. This was also your formula, and that formula will come in your previous year question to prove. Now next question is, now firstly I'm discussing some important question related to this formula. Next to your previous year question is, in triangle ABC, if 1 upon a plus c plus 1 upon b plus c is equal to 3 upon a plus b plus c, then then show that c is equal to 60 degree. Now the solution of that question was, we know that 1 upon a plus c is plus 1 upon b plus c is equal to 3 upon a plus b plus c. It was given to us. Now, take the LCM of a plus c and b plus c, which was equal to a plus c into b plus c. Now, b plus c will be multiplied here, and a plus c will multiply here. So, 3 upon a plus b plus c. So, in a numerator, you will get a plus b plus 2c, and in a denominator, you will get a plus c into b plus c is equal to 3 upon a plus b plus c. Now cross multiply, do cross multiply with there. Okay. So a plus b plus 2c. Okay, just a wait, huh? Before cross multiplying, you can write a plus b plus 2c as a plus b plus c plus of c, and in upon a plus c into b plus c, multiply with 3 upon a plus, no, is equal to 3 upon a plus b plus c. Now do cross multiplication. If you multiply, so you will get a plus b plus c whole square plus c times of a plus b plus c. A plus b plus c and is equal to 3 times of a plus c into b plus c. Now I'm repeating this line again in the previous in the next paper. So what we have got? We have got a plus b plus c whole square plus c times of a plus b plus c is equal to 3 times of a plus c and b plus c. So a plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Now multiply c inside. So ca plus cb plus c square, and in a left hand side you will get 3 upon 3 into ab, a into c plus ac plus c into b plus c square. Now multiply 3ab, 3ac, 3cb and 3c square, and in the right hand side you will get a square plus b square c square into c square plus c square, you will get 2c square plus 2ab plus 2bc wait, just a minute. 2AB, 2AB and 2BC plus CB is equal to 3BC, 2CA plus CA will equal to 3CA. Now this term will be cancelled, and if 3C square come to that side, so you will get A square plus B square plus 2C square minus 3C square is equal to 3AB minus 2AB. So it was equal to A square plus B square minus C square, and upon 3AB minus 2AB will be 2AB. So A square plus B square minus C square, sorry, 3 minus 2 will be 1, is equal to AB upon AB equal to 1. And that was the value of cos C, which angle will be minus C. So A square, we have seen in the write A square plus B square minus C square upon AB equal to 1. Now half the angle both sides. So you will get A square plus B square minus C square upon 2AB is equal to 1 upon 2. Now that was the value of cos C. So cos C is equal to half. So if cos C will be half, then C is equal to cos inverse of 1 upon 2. And whose value is 1 upon 2. So cos inverse of cos pi by 3 is equal to 1 by 2. That means pi by 3, which is equal to 60 degree. Okay. So that was the value of, so that was the value of C angle. Okay. So we have proved this is your previous year question. Now next question is, in a triangle ABC, if A ratio, B ratio, if A ratio, B ratio, C is 7 ratio, 8 ratio, 9, then show that show that cos A ratio cos B ratio cos C is equal to 14 ratio 11 ratio 6. Now solve it. We have given A ratio, B ratio, C is equal to 7 ratio 8 ratio 9. If we break the ratio, then we will get a value A is equal to 7K, B is equal to 8K, and C is equal to 9K. K means a constant because they are in a same ratio. So we did not get a particular value for them. So we take a common ratio K for all of them. Now the value of cos A. Cos A, what is the formula of cos A? How I can remember you? Uh, cos A, side corresponding to A will be A square. And now, which two side will be left? B square or C square. So B square plus C square, and in a by 2BC is also again. So put the value of B here, 8K whole square plus 9K whole square minus 7K whole square, and in by you will get 2 into 8K into 9K. So 8K is equal to 64K square, 9K equal to 81K square minus 7K equal to 49K square, and upon you will get 2 is a 90, 69 is 144k. Now on solving, you will get 64 and 1415, 600, 145 and 49. So you will get the value 98k square, 96, 96k square upon 144k square, k square. So k square term will be cancelled. 16 6 are 96, 69 are 144. Now if you more cut it, so you will get the value of cos A as 2 by 3. Now the value of cos B. So cos B, what is the formula of cos B? Which side was corresponding to cos B? B square. Now two side which was left, A square plus C square upon 2AC. So what is the value of A here? The value of A is 7k and the value of B is 8k. So value, sorry, A is equal to 7k whole square plus the value of C will be 9k and the value of B was 8k. So 9k whole square minus 8k whole square and upon 2 into 7k into 9k. So you will get a value 49k square plus 81k square minus 64k square and 14, so 126, 126k square. So you will get value 49, 64, just a minute. So 11, yeah, 7 and 1.6, 17. So 17 and 49, 7 and 9, 6, 66k square upon 126k square. Now, if you cancel, if you cut by 6, so you will get 11 upon 6 to 21. So the value of cos B is 11 upon 21. Now the value of cos C. So cos C is equal to A square plus B square, and which is the side corresponding to C, is C square upon 2AB. Now the value of A is 7k whole square, the value of B is 8k whole square, the value of C is 9k whole square upon 2AB, 2 times of 7k into 8k. Now the value of 7k is 49k square plus 64k square minus 81k square and upon, sorry, 14, just a minute, 112k square. Now you will get the value 64, 104 and 104 and 9, 113, 113 minus 81, 2 and 11 upon 11 minus 8 will get 32 upon 112 k square, k square. Now this will be cancelled by 16. So 16 2 ja 32, 16 7 ja 112. So you will get the value 2 upon 7. So what are the value of cos A, cos B, cos C? So cos A is equal to 2 by 3 and we get cos B equal to 11 by 21. We get the value of cos C as 2 by 7. Now the ratio of cos A, ratio cos B, ratio cos C equal to 2 upon 3, ratio 11 upon 21, ratio 2 upon 7. Now take a common multiple to cancel this by. So 3, 21, 7. The LCM will be 21. So 21 times of 2 by 3, ratio 21 times of 11 upon 21, ratio 21 times of 2 by 7. So 7 3 is 21, So 7 3 are 21. 21 will be cancelled. 3 7 are 21. So 7 into 2 will become 14. Ratio 11. Ratio 6. So in that way, we have proved cos A ratio cos B ratio cos C as A ratio B ratio C. Okay. Now your next question is half angle formula. Half angle formula. So the formula of sine A by 2 is sine A by 2 is equal to under root of S minus B S minus C upon B C. Similarly, if now remember one thing, how you can remember the formula of sine B minus C. Now see what is there? A. And in the formula, A was not come. So S minus of take any side B or C, and S minus of if you take here B, then you can take here C, and upon which two side you have taken that BC. Okay, that multiple. Similarly, how we can find the formula of sine B by 2? Which two side will not come here? A and C. So S minus of A into S minus of C upon AC, and the formula of sine C by 2 under root S minus of A, which two side will be left? A and B into S minus of B upon AB. So that were the formulas of sine A by 2, sine B by 2, and sine C by 2. Now similarly, the formula of cosines. So what are the formula of cosines? So cos A by 2 is equal to under root of S minus A upon BC. Okay. Now here, if A will become, if A will come, so corresponding side will be minus, and two side which was left come in by. So similarly, we can find the value of cos B by 2. So which is the side corresponding to cos B and angle B, that will be small b. So S into S minus B, and which two side are left? A and C. Now the formula of cos C by 2. Cos C by 2 is equal to under root of S minus C, and upon which two side will be left? AB. So that are the formulas of half angle formula. Okay. Now next is your the formula of 10A by 2, 10B by 2, and 10C by 2. The formula of 10A by 2. So the formula of 10A by 2 is S minus B into S minus C upon under root of S minus A, S minus B, S minus C, where S is your semi-perimeter. Huh? So you can simply tell that S minus B upon S minus C upon delta. That was the value of 10A by 2. Similarly, you can find the 10B by 2. Now remember the formula, how you can remember. In 10A by 2, A was not king. Rather, two side will be minus. That means B and C, and upon the delta will come. So the formula of 10B by 2 is S minus A, S minus C upon delta. This was the value of delta, huh? Where delta equal to under root of S minus A, S minus B, S minus C. Now the value of 10C by 2. So 10C by 2 is equal to S minus A, S minus B upon delta. So that are the values of 10A by 2, 10B by 2, and 10C by 2. And the formula of cot A by 2. Cot A by 2. So cot A by 2 is equal to S of S minus A upon delta. So in cot A by 2, A was came. Okay. Rather two sides will not came. The value of cot B by 2. Cot B by 2 is equal to S of S minus B by delta, and cot C by 2 is equal to S of S minus C upon delta. So that are your half angle formulas. Now come to in radius part. Uh, in radius, what is in radius? Suppose that was our triangle A, B, C. If a circle is touching all the sides of a triangle, then the radius of that triangle is known as the inradius. It is denoted by r. The value of r is delta upon s. That means area of triangle upon semi-perimeter. Area of triangle upon semi-perimeter. Semi-perimeter. Now, the important results of in radius are, if there will be a triangle A, B, C. Side opposite to angle A is small a, side opposite to angle B is small b, side opposite to angle C is small c, and that was the circle. The radius of that circle will be small r. So the value of r is here a upon cot b by 2 plus cot c by 2 plus cot c by 2. And if a was not here, b will came. So rather two side half angle of cot. So cot a by 2 plus cot c by 2. Next, c upon cot a by 2 plus cot b by 2. That was the value of small r. The next value of r will be, r upon s. Now next concept is of your in radius r. Suppose that was your triangle. Suppose you have put a line here and a line here and a middle. This is known as r, the main radius. R1 is small radius, that is small distance. This distance is known as r. Sorry, this was r1. This was r2. This was r3. So here r1 equal to s times of uh, r1 equal to 4r times of sine a by 2 cos b by 2 cos c by 2, and r2 is 4r times of cos a by 2 sine b by 2 and cos c by 2, and r3 is 4r times of cos a by 2 cos b by 2 and sine c by 2. Okay, so that are some important results of your properties of triangle. And in that chapter, we have discussed 3 4 questions that are come in your previous year related to these formulas. Now, in next part, I will discuss all the important questions that are coming that had come in your previous year exam.